We're going to work through setting up some stoichiometry problems. The first says a flask of mercury contains 3.77 times 10 to the 22nd atoms, and it wants to know how many moles of mercury are in the flask. And so we need to remember this really important conversion factor that's Avogadro's number, which is 6.022 times 10 to the 23rd atoms equals 1 mole. Now, anytime we do a conversion, I really recommend you set up what I call the train track. And the reason why is because if you set up your units correctly in the train track, you will always, always, always be able to solve the problem. Now, the way it works is if we're starting with atoms and I need to get to moles, I need to set up my conversion factor to where atoms is on the bottom and moles is on top. Now this is my conversion factor. The line right here between them represents the equal sign between them. So if I know my conversion factor, which is that 1 mole is equal to 6.022 times 10 to the 23rd atoms, well, then I know how to convert from atoms, which will cancel out, to moles, which is what I need. Now each of these, this represents multiplication, and the solid line right here represents division. So if I multiply everything on top and everything on bottom, and then divide these two numbers by each other, I should get the correct answer. So I'm going to take 3.77 and I'm going to divide that by my Avogadro's number. You should get 0.0623 sig figs, remember, moles, because those are the units that I needed. So let's practice this with another type of problem, which is what is the mass, this is grams, of this many moles of oxygen gas. So I'm starting with moles, and I need to go from moles to grams. So you might be asking yourself, well, what is this conversion factor? And in this case, the conversion factor is going to be the molar mass, which is in units of grams per mole, which is the same as AMUs, atomic mass units. So in this case, oxygen has a mass of 32 grams for every 1 mole. My moles will cancel out, so then I'm going to multiply everything on top. So I'm going to get 21.152, divide that by 1. It's going to be 21.2 grams because of the 3 sig figs. So the thing about conversion factors here and here is that the number of sig figs is considered to be infinite. So we're not going to count those when we report our final answer. We're only going to worry about the number that we're starting with because that's our measured value. So let's practice another stoichiometry problem. We're going to practice this one right here, and then you'll have a bunch of 3 to practice with. So this is given the following balanced chemical equation. It's a combustion reaction. How many moles of water can be formed if this many moles of pentane are reacting? So when I solve these problems, I like to set up where I'm starting and where I'm going to. So in this case, I'm starting off with this many moles of pentane, and what I want to know is how many moles of water can be formed. And I need to be able to convert between them. So in this case, the only way to determine how many moles can be formed from how many moles I have is the mole-to-mole ratio that I get from a balanced chemical equation, which I have here. So if I'm going to start off with this many moles of C5H12 per the problem, but my balanced chemical equation tells me for every 1 mole I can make 6 moles of water. What this means is if I start with this many moles, I can make 6 times the amount of water than what I started with. And so in this case, I'm going to take 0.0652 times 6 and get 0.391 moles of water. So the mole-to-mole ratio that I needed is right here. Now, let's say, like in the problem you're going to see here, I'm starting with mass. Okay, so if I start with grams of something and I want to get to grams of something else, I have to do what I did up here, which is first I have to convert to moles of A, if that's what I'm looking at, moles of A, grams of A, moles of A. Then I have to convert to moles of D. And I do that, and then I can convert to grams of D. And so to go from grams of A to moles of A, we're going to use the molar mass of A. To go from moles of D to mass of D, we're going to use the molar mass of D. To go from moles of A to moles of D, well, that's just like what we just did, which is the mole-to-mole ratio based on the balanced chemical equation. And this allows us to go between A and B, A and C, B, D, C, B. It doesn't matter what the problem is or who is in the problem. This is the general outline to convert any and every problem that we might see in stoichiometry.